everybody has been talking about the major changes that large language models are bringing today. You even can see a very nice tweet from Andrej Karapati that was saying, the hottest programming language today is English, right? So the transformation was at the beginning we were actually coding. In the last, I would say, 10 to 15 years, we've been actually building machine learning models. And today, we're all prompting. And I want to kill all of this excitement in this talk, right? So pretty much what I want to claim is that large language models are like mainframes in the 1960s. How come, right? We're all centralized computing. You're all going to the same GPT. We're all doing time sharing. Nothing is on my computer. We're all talking about like operating system in the cloud, and we have apps that are running on LLMs. We're sharing the computer, transfer switches like OpenRouter and others. And there's a lot of stuff that we can still develop. Right now, as in the 60s, mainframes were mainly used by companies who are really rich. Who are the companies who are very rich? Governments, right? So today, it's companies who are spending, and hear this, $70 billion per data center, right? So what's happening in the last, I would say, few months? We've been actually seeing how all of this can be significantly decreased in price, both the training and the inference. And you can see some of these new innovations like BitNat are saying, you know what, you don't need all this sophisticated weights in those large language models. We can move to ones and zeros and therefore be much cheaper, use less energy, and therefore pretty much the opportunity for you startups is bringing all of this excitement to your personal device. But for me, it actually brings a lot of new algorithmic changes that can happen. Because if everything is going to be cheap, instead of building large language models, we're going to start seeing small language models. And what does that mean? It means models are very specialized in a certain task. And then we are trying to solve a very big task. We're going to have a swarm of those agents trying to solve it all together. But it's pretty much going to talk about, and we use this term many times in many industries, democratize those large language models. But what it actually means is much cheaper specialized models who are learning how to work together to solve different tasks. Now, again, I'm going to move to the latest talk from Andrej Karapati, who had a very nice talk. And he was talking about the fact that he doesn't believe in autonomous agents. He believes in this collaboration between human and AI. So we've been calling this, again, for the last 20 years, human-computer interaction and how AI can help humans. And I want to say, yes, this is what everybody's doing right now. This is all the startups. And you can see like Cursor, right? You're not telling it, build me this amazing system, right? You have like almost like a bar that gives it how much autonomous you want it to be, right? But you're using me, a human, as a QA agent. And I think we've studied enough not to just do QA. Even in more sophisticated things like Perplexity, it gives you like an adjustment autonomy in the UI, how autonomous you want it to be. And I, unlike Andrej Karapati, do believe that we're ready for autonomous agents. And how come? I think right now there is almost zero adoptions of those agents in production systems, right? Yes, engineers are using it as crazy, but in most enterprises, people are not using this because it's not ripe, right? There's a lot of buzz, but still not a lot of usage. Everybody's talking about like these agents who are actually doing the browsing and everything. They call it like OS agents, but eventually most of the operating system tasks are still not controlled. So in other words, how can we start bringing it to be fully autonomous without using the human as a QA agent? So and again, I'm going to be sharing examples from my personal story, right? So I've been running a company called Diagnostic Robotics. We've been building systems to automate a lot of the work of care managers, which is almost like nurse practitioners who are doing, it's almost like a call center of nurses calling patients up and doing proactive care. So instead of thinking, okay, half the sentence is going to be done by a human, half is going to be done by an agent, then half a human, then half an agent, we're actually doing the call itself and calling the patient, having a meaningful conversation. Hopefully, if I click on this, it will work. No, it doesn't work. Okay. Oh. Sorry about that. Okay. In general, what those systems have is having a very natural language conversation with patients, talking about why are you not taking your medications, when are you going to start taking your medications, can I help you, can I register you? But what we didn't do, we did not tell the patient, wait a second, I'm going to move you to a human to have a more meaningful discussion. The next thing that we started hearing a lot, and why not use fully autonomous agents, is the fact that they're not controlled. In other words, we want governed autonomy. I want to show you first versions of the system, right? This is actual phrases used by the agent with a patient. I understand that you're going through a tough time, but it's important to remember, others have it worse, right? In other words, it's not nice, right? So we started building all of those pillars that we're measuring, and it's not about bias. Bias is just, in my opinion, just a PR that has been used since like a nice paper published in 2019 that they were saying AI is biasing against minorities and women and everything. But there's so much more beyond just bias. It's actual personality. When you hire somebody to your company, you're not measuring, is this person biased or not? You're measuring personality fit. That's what I want you to think about agents as well. But for this, you got to measure much more things. So for us, it's how many times you're staying on the script, how many times were you nice to the patient, how many times you actually forgot something. In other words, are you a good employee? So I'm going to claim that bias is a very 90-80 problem. And what I want us to focus is much more complex elements of psychology for those agents. So for example, I want to claim that narrative is a much bigger problem than bias. Both of those news articles are being reported once by Ukrainians and once by Russian. At this point, I don't even know what actually happened, but here's the translation. The Ukrainians are discussing that local residents organize a collection of medicines for the victims. Notice how Russians are describing exactly the same one. Local residents in the occupied city organized a collection of medicine for their, comrades, let's say, who were affected by our military action, right? It's the same event with two different views. What view will your agent develop? How can we control the views? What is the right view? We don't even discuss those things, right? So in the latest works we've been seeing from Anthropic, they were discussing about how those AI agents develop personality, and they actually found different parameters in the model that you move them, and it makes it evil. Why evil? Because then you get published in like Washington Post or something like that. But right, if you would have been nice, nobody would publish about this. But the cool idea was there's like literally parameters who make you cool, nice, and what I want to start actually pushing is, can we get, and this is a little bit technical term, monosymatic features about talking about how can we have those knobs to control the personality of those agents so they're going to be autonomous, but still a good fit for the DNA of my enterprise when we use them. Now, the next thing I want to claim is, AI is really cool, but all it does is produce digital currency. I want to claim if you really want agents, I want them to be alive. And for alive, they have to produce something physical. They have to produce something. So till today, we've been mostly talking about, oh, yeah, it's going to go and browse on the web. Cool. But that's not what I want. I want a system that's going to produce me elements. I want it to produce molecules. I want it to actually go and do something in my factory. Because if you think about this, there's numerous elements here. A manager in a factory doesn't do the work always. It sees people and it tells them what to do, understands what was done, and then tells them what next to be done. And definitely AI can start producing this. So let's start moving from digital AI to physical AI. And a little bit, if we look at metaphors, we're moving from mainframes to PC to internet, but we actually, what I want to do is physical embodiment of our AI. So what is the next thing that we're trying to do is, I'm going to show you an example of Mana that was producing molecules based on an instruction of an AI agent. So first of all, what is exactly Mana? Mana is a company who's using AI for mRNA delivery. What is mRNA delivery? Remember mRNA from COVID times, right? It's a message that gets to a cell, makes it produce a protein. You can cure cancer if you can actually produce like antibodies against your own cancer, right? What's the problem? Creating this spaceship. Like into what do you put this mRNA that will reach the specific cell and not to just like random place in space and kills the astronaut, okay? So what's the biggest problems? Everybody had this dream, can we build those spaceships from LNPs? Okay, fats, right? The question is how? How do we build this? So we started using AI systems. The AI system first started reading all of the medical literature. We actually pushed it, all of those things chemists were writing. And then we asked it, well, just tell us the recipe. Like a cake recipe you might ask from GPT, right? And here are the results. We said, can you produce me something for the liver, right? So it actually, we had 80,000 stuff we could produce in the lab. because we didn't have money for other stuff. And we filtered out the first ones which were patented, and the first ones were those. And what you see in mice, this rat thing, it means it reached to the liver. You see, MC3 was something that took 20 years to discover. Here, it was discovered in 3 months. And both of them are patented. Since then, it actually reached to T cells, which is extremely awesome if we're talking about immunotherapy and how we can treat cancer. Just implication perspective, imagine something that costs today $10 million to do in $100 and treat cancer in any stage almost by getting your immune system to do it. And what's cool for me is we have an embodiment of AI who managed the entire process. And the way it was doing this is around causal LLMs. What does it mean, causal LLMs? And this is, for me, the future of where agents are going, is how can we help those LLMs understand the impact of their actions? Most machine learning models are thinking about correlations. Oh, this happens and this happens approximately at the same time. But what it actually needs to do is experiment in the world, understands the implications, and learn this. Luckily, somebody got a Turing Award for this approximately, I think, 12 years ago. Judah Pearl, and the idea is how can we take those classic theories, again, 12 years ago is pretty classic, right? But get LLMs to understand their actions and actually work in the real world. So kind of, if you have numerous things to take from this talk is, we're still in the mainframe area. Don't look at your agents as something that's gonna help you and you're gonna work with them. Think about them, how do you create amazing entities? Stop fearing them, help me control them in a better way from a scientific perspective, and we want to get to a point where we have physical agents as opposed to the digital currency that they're now producing. Thanks so much.